Hello, everyone, again. This is, of course, a second panel about utilities. I'm Rémi Demerlet. I work at Semtech in marketing for LoRa. I'm here also to moderate a panel about smart water metering, why it's important, why also we don't only consider metering as the only alpha and omega application of everything. On contrary, IoT is made of collaboration between partners. You will see that. Collaboration of different devices. You will learn that. And to create also tangible benefits for end customers. And we will have here also end customer, utility, system integrator, platform vendor, and network operator. So almost all the value chain. So just to recap why it's important, sustainability, how to empower utilities with solutions that can help to reduce non-revenue water. To reduce non-revenue water means a better measurement capability, a better system to know almost real time how much water is produced, how much water is consumed, and by difference, to observe if there is something missing, apparent or physical loss. They are what we call non-revenue water, water that are unbilled. It's in average 25% of clean water produced that is not billed, meaning there are leaks, meaning there are some operation, sometimes water is not counted. It's one of the challenges. The other one challenge I can see for, I would say, business side is about 1 billion of endpoints do not have any meter. That's a huge potential market. So there is also other significant numbers, and you will see that in the next session after the panel. What are the size of the market for water metering? But I wanted also to make clear why we consider within the LoRa Alliance the value of the technology for water metering is because LoRa modulation was designed for solving the problem of connecting a water meter deep underground in a water pit, almost 1 meter down, under iron cover or different plastic cover, but making very hard for radio signal to penetrate. So the radio was designed exactly to overcome the limits of other radio modulation that were used at the time, 10 years before, 12 years before, within the European market. So it's my pleasure to welcome on stage my guest for this panel, Antonio from Acquedotto Pugliese, Frédéric Jourdain from NTT Data, William Angelis from the city of Brussels, also Marco and Morten from Lyse Network and Infotiles. Please have a seat. Welcome, guys. So we will begin our panel. They will present turn by turn what is their experience, what the use case. We will begin with Acquedotto Pugliese. Antonio is the head of metering. He is coming from Italy. He will give us also his prognostic for the European Soccer Championship, maybe, or not.
Thank you.
But the floor is yours. Thank you.
Thank you. Good morning, everyone. I'm Antonio Caggiano. I'm the head of metering of Acquedotto Pugliese. And today I'll talk to you about the meter asset managed by Acquedotto Pugliese. But above all, I will illustrate you our smart metering plan, which is in progress and involves the replacement of all the old mechanical meters with new smart meters. Furthermore, the smart metering plan requires that all the meters will be read remotely by a fixed radio network. Acquedotto Pugliese is one of the largest Italian water companies and a leading European player in the management of water and wastewater systems. Manage the integrated water service of Puglia and for a total surface area of 20,000 square kilometers. Acquedotto Pugliese is in charge of about 4 million people served and over 1 million customers, all of them equipped with meters. As you know, in water smart metering, walk-by and fixed network are the two common communication methods used to collect and transmit data from water meters to a central data management system. Briefly, you can see here the main difference between walk-by and fixed network system. The first difference is about the communication method in a walk-by system. Meter readers or data collectors physically walk or drive by the meters to collect data. In a fixed network system, the water meters transmit data to a central data collection point without the need of physical proximity. The other difference is about the data collection frequency. In walk-by system, it occurs intermittently. When a meter reader is in close or proximity to the meter. The fixed water system enables continuous or frequent data collection. The other difference is the cost and the scalability of the system. The infrastructural cost for walk-by systems is generally lower, as they do not require a dedicated communication network. Implementing a fixed network involves higher upfront infrastructure costs for establishing the communication network. However, over time, it may result in cost savings due to the increased efficiency and reduces labor costs. Furthermore, fixed network infrastructure allow the daily acquisition of consumption data alarms, thus enabling the digital evolution of the smart water grids. It is clear that the real efficient option for smart metering is the fixed network. For all of these reasons, Acquedotto Pugliese believed that it was not appropriate to start the digital transition process using the walk-by method. But rather than it was appropriate to wait for a technological development that would allow the true benefits of smart metering to be obtained, those of the fixed network at sustainable cost. Now I will show you the legislative and technological context. In Italy, fixed network smart metering in the water sector is currently and rapidly undergoing advancements due to the growing development of the low power wide area network. And the main difference compared to the traditional wireless communication protocols is the range of the radio communication between the gateway and the meters. In urban areas, this distance increases from a magnitude of 100 meters to up to 1 kilometer. So a growing number of water utilities in Italy are therefore considering the utilization of low power wide area network for automatic meter reading with much lower cost than in the recent past. Furthermore, today in Italy, the law does not require the use of smart meters or smart meter technologies. Acquedotto Pugliese so starts its smart metering project when it deemed the technological context to be developed enough to employ a technology that would allow the implementation of the fixed network at sustainable cost. Low power wide area networks, in fact, enable radio coverage of large areas with few gateways, resulting in relatively low cost for building the fixed network. Acquedotto Pugliese firstly decided on the massive replacement of 1 million mechanical meters with smart meters implementing 100,000 per year starting from 2021. And secondly, we decided the automatic meter reading management through a fixed network for an investment value of approximately 16 million euros per year. At the end of September 2018, Acquedotto Pugliese launched a preliminary market consultation aimed at the selection of the best technology for the automatic meter reading, and the goal was to identify a communication protocol with the technology development ecosystem Technological requirements of the consultation were, you can see bullet points on this slide, proven communication technology, short-term production of static meters, low battery consumption compared to the other communication technologies, no vendor lock-in conditions, sustainable implementation cost compared to the other technology, and experience of network operator. Among the various communication technology analyzed, the one that best met this requirement was LoRaWAN. Acquedotto Pugliese requires static meters with dual remote communication protocol. The LoRaWAN for the fixed network, which was the protocol that emerged in the choice of the Masker consultation, and the 868 wireless M-Bus for the walk-by, drive-by metering. This second protocol, working simultaneously with the LoRaWAN, was required to collect the data from smart meters out of the LoRaWAN network coverage. As you know, no radio network allows to reach the 100% of device, or rather it allows at exponential increasing cost. There is a balance between sustainable cost and a good percentage of meters connected to the fixed network. Therefore, for those meters not connected to the fixed network, it was necessary to have a protocol for collecting data in proximity. This is the reason for having requested the double simultaneous protocols in the radio, one for the fixed network and one as a reserve for proximity collection. Alongside the procurement of the smart meters, 2 tenders were awarded for their installment, one in 2020 for about 240,000 meters, and one started in September 2023 for 230,000 meters. So far, the number of smart meters installed is around 190,000 smart meters. And at the end of 2020, Acquedotto Pugliese decided to implement the remote reading with the LoRaWAN fixed network through a service contract with the task of constructing and maintaining the LoRaWAN network. And this is a long-term contract to allow the payback of the infrastructure deployment. The tender was recently awarded for an 8-year service contract. As a compensation for the execution of the service, Acquedotto Pugliese provides a periodic payment per smart meter managed with a penalty mechanism related to the KPI not reached compared to the target values defined in the contract. One of the main objectives achieved by Acquedotto Pugliese smart metering project was the final cost of the data through a slow but structured process that paid careful attention to the technical specification. We managed to achieve a fundamental goal, obtaining the big data collected today at approximately the same cost as 2 traditional annual readings. In other words, at the same cost of 2 annual readings per meter, Acquedotto Pugliese today collects around 8,000 annual readings, in addition to any alert regarding leakage or abnormal consumption by users. Moreover, all of this without considering other known benefits of smart meter: accurate billing, user awareness of consumption, reduced carbon footprint, data useful for hydraulic modeling, and reduction of water losses in managed system. And finally, I would like to tell you about the future challenges that await us. The solution are expected to be deployed starting in 2025, and among the other opportunities, we have data analytics to make the management of water networks more efficient. Monthly, daily district water balances and advanced hydraulic modeling of networks, profiling consumption, and customer access to hourly daily consumption data and alarms. Thank you.
Thank you, Antonio. And next to follow, Frédéric Jourdain from NTT Data. So Frédéric is an IoT expert at NTT Data. He will explain the project with the city of Liege, where his customer, William De Angelis, will testify also. And William De Angelis is now CDO, Chief Data Officer, for the city of Brussels. The floor is yours.
Thank you very much for this introduction. So it will be a pleasure to be on scene and to share this success story of a sustainable project. It will start in 2017. So at that time I was the CIO of the company Sile. Yeah. That company is located in Belgium, and Belgium is a small country, but we speak 3 languages, and they've got 6 governments. So everything is quite simple, but could be faster, be complex. So at that time, the company covered 24 cities and delivers water to 600,000 persons. The water network is composed by 3,500 kilometers, more or less, and we've got 50 water tanks. At that time, we focused on how we could deliver new services to the citizens, how we could increase the performance of the network, and how could be more efficiently in the operation. So we work on these different axes. So the idea was to collect data, because today in the water sector, the data are reading manually, or we have to send agent to visit the consumer and to manually record the water meter reading. The same is on the different part of the network. We have to send a field operator or agent to measure. So the data is not a good quality, and when we do the consumption sometimes it's an estimated, because we invoice the consumer with estimated consumption, and once a year, maybe once every 2-3 years, we've got the real consumption. So it's based on estimation. The only way to improve this quality of data was to deploy different sensors to the network and to the consumer in this house, to have a better knowledge on the network and the consumption. Like that, we can balance the production for the consumption. In Belgium, I told you it's quite complex, and there is particularity. Telecommunication are quite expensive. So at that time, when we check with public telecom network, the price was more or less €1 per devices. So we've got more or less 300 meter, so it was €300,000 per month, more or less 3,600,000 per year, 3,600,000 per year. So there is no business cases. So we've started looking, was the technology could help us. We were looking at that time which kind of telecommunication technology could support data collection. And we were looking for Sigfox, for radio frequency, also NB-IoT. And we start playing at that time. It quite like an exploration. And LoRa was an evidence. Second particularity of a water company, so we've got this water tank, and a water tank by definition, it's a height point. So we can deploy antenna on our asset. The asset becomes strategic. So we deployed 48 antenna, and we cover like that 24 cities in order to deploy different kind of sensor. So once the barrier of the money was bypassed with our own LoRa telecommunication, we start to deploy different kind of sensor, metering, flow, quality. The first one was to deploy in the house of the citizen, of the consumer, so a smart metering. With this sensor, we can now have a correct consumption, so we can provide new services. We can provide digital invoicing, so we reduce the paper. We reduce also the movement of the agent to the house, so we reduce also carbon footprint, because we do not go anymore by car, making appointment and disturbing the citizen, so a better experience for the citizen. The second part was to better know our network of water, of course. So we deployed different sensors in order to see if there were leak, no leak, and also to put some sensor in the water tank. When do we have to fill full the water tank? regarding the demand. So we can reduce the energy and to fulfill the water tank when the cost of energy is low. The third one was the leak. With all of this data on the network, we do a better segmentation. So we've got data coming from, I will say, every 5 kilometers or every 10 kilometers. And we can, of course, with algorithm, find where is the leak. And, of course, go faster to repair the leakage and reduce the social impact and the environmental impact of the damage. With that LoRa network, we cover egoistically what the company needed to increase. But it was, for us, in evidence to also give the networks to the 24 city and to be a booster of the smart city. So we've been visiting the 24 municipalities, explaining, listen, we can provide you for free a motorway of telecommunication regarding the IoT. And by the way, and collaborating with NTT, we provide a portfolio of services. And now I think Frederic will explain to you the detail of the technology we used. Thank you.
Thank you, William. Yeah, I'm very proud to work with William on this project for years now, and we are continuing with Brussels City. Yeah, the smart city use case is very interesting because now we have a global coverage in the region of Liege, and we have a lot of discussion with city, mayor, and of course, a lot of citizens and companies to use this LoRaWAN network. And we are working with a private network, which become also a public network available for everyone. But the deployment was not so easy when we start for different reasons. And we make the comparison between Sigfox, Narrowband, IoT, and LoRaWAN. And the evolution of LoRaWAN was key in the decision we took for going to LoRaWAN. Of course, everybody knows about the capacity, the battery lifetimes, the quality of the payload, the encryption process, etc. But it was key also for CLA to make the decision about the cost of deployment, and how smart it is to deploy, the number of gateways available, the quality of the manufacturers, and the capacity we had to deploy on some region, some specific gateways. You know, the region of Liège have a lot of rivers, meaning that there is a lot of valley. The advantage of CLA was that they have already 52 water tower. That's nice. They have already the network. It was very easy then to plug the gateways directly to the OT networks and to protect them. Yeah, but right now we are still deploying the network. We are still deploying devices. And we have a monthly dashboard. And what we are analyzing also is the quality of the signal, the spreading factors, and the quality of the communication we have. This is the figures of a few months ago. Now we have more than 90,000 devices. The plan is to go to 260,000 devices, only for the smart meter, plus some meters located on the ground for the smart grid, as William explained. And what we are doing is a complete analysis, gateway by gateway, device by device, what kind of spreading factors, how the joint process is running out. We are working with Acquedotto Pugliese Enterprise, where we have a lot of configuration functionality and a lot of tools also to analyze the performance of the gateways and the performance of the sensors. We are working with CLA in a complete process, meaning that we still have consulting services provided to the client, but also we are working on the data layer. The advantage is that now we are providing some AI module. The goal is to be able, for the end of this year, to be able to predict the consumption water tower by tower, then tank by tank, because pumping the water from the ground is very important because of the needs, but it could be dangerous also because, you know, sometimes there is less water that we would like to have, and then pumping too much water on the water ground could be dangerous. The reason why to preserve the water in the water ground and to limit the quantity of water we are pumping from the ground, the predictability model is very important. We have enough data now to analyze this and to provide the prediction hours by hours, and we would like by the end of this year provide it for a 24 hours prediction model. Then there was a lot of benefits for this project, for CLA, with the alert management in terms of pressure. We have, of course, the invoicing process, the leakage prioritization to replace the pipeline. For the consumer, of course, the leakage detections and the consumption control. And for the society, more globally, for the region, we preserve the water ground and we manage all the leakage at home and in the distribution process, which give us real benefits in the carbon footprint impact. Thank you very much.
And now to continue, Morten Ovland, who is group leader for IoT at Lyse. Lyse is a Norwegian LoRaWAN network operator. With him also Marco Westergren, Chief Analytics Officer at Infotiles.
Thank you. It's a pleasure to be here in front of you. As you said, my name is Morten. And let's see if I can get this working. There we go. So I'm a tech lead of IoT in the Lyse group. We are a telecommunication and energy company. And through our brands, Altibox and Ice, we are the largest fixed broadband provider in Norway, and we're also the third largest cellular provider. We have been using LoRaWAN and building public networks since 2018, together with our partners in the Altibox partnership. And with me today, I have my colleague from Infotiles.
Thank you. So, I'm Marco from Infotiles, and before I worked in software, I worked in data management within a combined utility, which was just large enough that the problem was, in fact, complex, but not too large that it was impossible to have a personal relationship to everyone in the value chain throughout the operation. And what I found was the software currently available was more of a hindrance than an aid when you're looking at interconnected problems. So we do work with IoT data, SCADA data, GIS information, and basically anything that you can enable cloud connection and combine them to provide deeper insights.
So we are here today to talk a bit about a use case that we have in Norway, which is replacing analog water meters with LoRaWAN-based ones in the municipality of Trondheim. Trondheim is the third largest city in Norway, and they have already been doing analog water meters for quite a few years. Last year, they put out a tender to replace all these meters. And one of the requirements in the tender was quite interesting for us, because they had a requirement that only LoRaWAN-based operators could apply. And this was based on pilots that they had with other competing technologies. And they saw that the standardization and openness of LoRaWAN gave them the courage to go for a fully digital water meter. And that this is actually quite interesting, because this is something we see across many municipalities in Norway, that the LoRaWAN has the strength to avoid vendor lock-in for 10 years if you go with one of the more traditional meter manufacturers. They want to be able to replace parts of the value chain when they want, when there are better solutions available. And that's a very good opportunity to cooperate with partners in the LoRaWAN space. The scope for Trondheim is 60,000 meters over 5 years. They require multi-vendor support from day one. And the end goal is to enable automatic meter reading, of course, and invoicing, but they also want hourly insight into the consumption and distribution of data. This is, of course, has lots of benefits. One of them is to reduce water loss, which Trondheim has about 30% loss. And they want to improve their mean time to repair if there's an outage in the network. A little bit about the network itself. I'm not going to spend too much time. An interesting point is that it was decided to build a public LoRaWAN network that's not only dedicated for smart water metering, but also other use cases in the municipality, but also give access to other companies in the region to enable innovation and accelerate use of IoT. Together with the municipality, we are allowed to build a network using municipal infrastructure, which gives us cheap and fast access to roofs, and it's a great way to build a network. And then I will hand over to my colleague.
Thank you. So one of the reasons it works so beneficial is that within the technical department, there's not only one need. So the capabilities of solving multiple with the same technology is seen as highly beneficial. And with development in technology, we don't know whether the meters that are optimal today will be the same in 10 years. But one thing I've learned coming from the utility sector is change isn't necessarily popular. We want all the benefits, but we don't necessarily want to change the way we work. Can we solve that using technology? So there are a lot of moving parts in the value chain here. First of all, you need to move the physical meters from production to the warehouse. And traditional analog metering systems, you deal with legal, financial, serial number, meter reading, not necessarily understanding the different pros and cons of different radio technologies. So what we do as the man in the middle, we operate between the pre-existing billing system, where they have all the legal required records to maintain for 10 years, and also enable them to use the same provisioning as they used for analog meters. We do all the automatic behind the scenes. So non-revenue water is the #1 target, but before you can track non-revenue water, you need to know the mass balance. How much do you deliver? How much do you extract? But we wanted to see not what can we do in 5 years after everything is deployed, but how soon can we provide accurate measurements across the 114 district metering areas. So anytime a plumber fixes a device, we pick up the location, we automatically map it to the district metering area and extrapolate what would it be if we had 100% coverage already today, less than 6 months after the first meter was deployed. This also reduces the need for manual labor and metadata management and allows us to keep track of a moving target as district metering areas change. They become smaller and more numerous. But moving from pure analog into pure digital is also scary from a citizen point of view. Is this private personal information? Can they check whether I'm home? Is it secure enough? So we were tasked with, can we enable a need-to-know basis, so not everyone in the technical department can look up a single meter but still get the numbers they need to solve their daily tasks. So we aggregate by 10. If you query for a smaller region, you'll get an empty return that's beyond your need to know. And we also make sure that they conform with SCADA readings across metered areas. And the operators and planners aren't necessarily interested in what is a single meter reading, what is a single meter development. They want to know bird's eye view. Can I use this information to optimize my entire network? So we provide early value through analytics. Can we discern whether it's water loss or illegal extraction? Can we simplify it as far as possible so you don't have to be overwhelmed with information? And smart meters have the unique position of being in the middle point between water distribution and wastewater collection. It's the only data point you have to verify mass balance, both across what you receive as sewage as well as deliver as potable. But we provide a digital outcome, and the people in visibility clothing, they aren't necessarily concerned with the digital outcome. They want to know, based on the data, what should I do right now, tomorrow, next year? So what we do is collect all this information and boil it down to which pipe should you inspect first, rather than giving tens of thousands of readings, 4 different computer systems, and leaving it up to the end user to discern what should I actually do about this. As I mentioned, we're just about getting started. We are currently done all the integration work, the billing system, the mapping system, the activity, tech stack, and currently we're on track, rolling out 1,000 a month, and are already achieving value. Thank you.
Thank you again, Marco and Morten, for your use case and to share this experience. So we have seen various deployments in different geographies. All are also targeting to help in sustainability. But the choice of connectivity, I want to get back to that question. What are the key features about connectivity were important for the utility in the selection of connectivity? Can you maybe reshare again this experience with Trondheim, the comparison?
So in my experience, it doesn't really, like, of course, the LoRaWAN technology is very important. It's more battery efficient and more standardized. But what they ended up caring about more in the end is it's simpler logistics. Just simple things like no SIM card, for instance. If you want to switch network providers, you can do it without visiting 60,000 meters. And all of those things add up more than 5% more effective on the technology, the radio side. Yeah. So it's everything around the openness and flexibility. Yeah.
NTT Data, maybe you want to also
comment? It was very important for us to also to mix the daily work of CLE worker, field workers, and the technologies to avoid any process change, etc. Then the smart meter replacement, the lifetime is 16 years. And the idea was also to try to be able to provide a network which have the capacity to receive all the information with then a correct communication layer to save the battery of the meter itself. And then we tried to analyze different spreading factors, different position of gateways, what are the best solution, how many gateways we need, where to put the gateways, etc. Then the preparation of the project was very important to be sure that we are able to go underground, under 1, 2, 3 meters, and to receive a message, and then save also the battery of all the smart meters. This is what we realized with LoRaWAN. And I think it was the only technology that we can use for that.
Thank you. And Antonio, you explained already the choice of dual connectivity to complement LoRaWAN fixed network with a system for walk-by, drive-by. Mm-hmm. I wanted to insist the walk-by, drive-by support will be available in the next LoRaWAN specification. It's a work in progress. So maybe that will be an
good news.
But can you insist again on the key features or the key requirements about connectivity for your company, the utility company?
Yes, it was, as explained in my slide, it was We need a proven communication technology, low battery consumption, no vendor lock-in conditions. It was important for us. And a developed ecosystem of network operator and meters manufacturer. And so LoRaWAN was the best technology that met all of those requirements.
Thank you. So I want to rebound on this no vendor locking. There is an important value in standardization, in my understanding, in this smart metering market. Could you share with us what is important in your countries or with your customer about the choice of standard for device, for protocol, or for other, I would say, visualization of data, for example? Can you continue to develop?
Yes, we decided to separate the steps of a smart metering plan. So we decided to separate the choice of the best meter and the choice of the best network operator. And you can do this, you can choose the best meter and the best network operator only if you have a standardized communication protocol. So anyone who wins the tender for the meters, the data could be collected by the network operator that wins the tender of the network. So that's really important to have standardized communication protocol.
Yes, and also now in Europe, you've got a lot of regulation. You've got the Data Act, Data Governance Act, and you've got also Interoperability Act. So for my new job now, I'm working for the Smart City of Brussels. So we should use data models to exchange with other cities in the way to maybe do digital twins to compare some use cases. So yes, the choice of the data models of standards, it's very important for interoperability.
So I have a slightly different angle. Most European utilities are public, which means they are liable to follow the laws of public procurement from country to country, which means making the wrong decision is not only costly in pure money terms, but there's a huge loss of time. The amount of preparation, public tendering, complaints, the timeline could be years between detecting when you've made a bad call before you can actually do something about it.
So to also insist on this value for the utility and for society about sustainability, can you give one example of application, not based on metering, that will leverage on IoT for sustainability?
Yeah. An example for us, we provide new services. So when you know your consumer, maybe you can, with information, try to change the behavioral consumption. So like that, during the summer, maybe to don't fulfill the swimming pool regarding to the weather forecast.
And to complete, as I explained, preserve the water before using it, before cleaning it, then having a real control of what we need before taking from the ground or from the river is very important. Then just use what we need. That's the first with the meter. But on the top, being able to predict the needs, because the problem we have with the weather change is that it changes always. All the previous things we had, a previous analysis we had before, are not relevant anymore. Now, every month, we have too many rains or no water at all, and depend. And this is what we see Europe-wide in each country. We have discussion with Spain, with Italy, with south of France. Yeah, they had problems a few months ago, and now they have too much water. Then having a correct predictability model will be very important for the sustainability ambition that cities have right now.
Thank you. And quickly to finish.
Yeah, one use case that's very interesting both in Europe and globally right now is when When there are blockages in the sewer network or the precipitation exceeds capacity, you get spills of untreated sewer into nature. And without measurement, whether it be aggregates of smart meters or local level readings or flow measurements, in order to target them and actually reduce them to ensure it's safe to swim in local rivers and lakes, the IoT is a crucial component in solving the problem.
So I want here to conclude and to ask you to give a warm applause to our guest speakers. Thank you again for all your presentation.